Hello everyone and welcome back to our course. In this lecture, we're going to learn how we can rank feature importance in several ways. So we'll find which features are the most important. All right, so let's create a new code cell in our Colab. And first we have to import from yellowbrick.features. We are going to import the class rank1d starting off. This is going to instantiate or allow us to instantiate a one-dimensional visualization with the Shapiro ranking algorithm. So I'm going to call rank1d, and in here I'm going to pass in several arguments. Okay, first off, I'm going to pass in the features that I want to include inside of my ranking. So in our case, my features are going to be the columns of the data set that I find are relevant. So let's first create our features. I'm going to create a features argument. Now let's see. Previously, we don't have it, so yes, we do have to create it. I'm going to grab our data set and grab the columns that we have. So we have open, as well as high, low, volume, with a capital V. We have decrease. Then we have buy, and finally we have returns. Okay, so those correlate directly to the columns we have. Then the result of features I can paste out, and here we go. This is our data set. We can also call features.info to get information about it. All right, so this is just our data frame. You could also use the data set, but I just want to make sure you know how you can specify which columns you want. All right, then I'm going to create that new code cell, and I'm going to call rank1d. I'm going to pass in my features argument as my features variable. Then I can actually choose any algorithm I want. We can do Shapiro. That is going to be the Shapiro ranking algorithm, of which there are several Shapiros commonly used. The result of this is going to be our visualizer. So I'm going to create here visualizer as a variable. Then I can call visualizer.fit, and I'm going to fit our visualizer through our data. So you may be thinking, what is our data? Well, we have to define X and Y for the data. Typically, X is capitalized, Y is not capitalized. X is the independent variable, or the features, and Y is the dependent variable, or what we're trying to predict. All right, so I'm just going to create a new code cell and define X and Y, or I could do it in the same code cell, doesn't matter. Okay, X is going to be our features, but we have to convert it to a NumPy array with this function toNumPy. A NumPy array is like a list, like a Python list, but it's much faster, and also it's exposed to a lot more sophisticated functions, such as, any kind of scientific computing functions from the NumPy library. Very, very commonly used. All right, now what is Y? Let's define the dependent variable. This is what we're trying to predict if we were doing a machine learning project. It's the output we're trying to get to. So I'm going to grab my data set, and I'm going to choose one of our columns. For example, typically adjusted closing price is used. That means we're going to use all the other features to predict this feature. And then we can use toNumPy. In fact, we have to, because we have to take that column and we have to turn it into a list. All right, then I can paste Y, and I will show you the results. There we go. Now, X is two-dimensional because there are multiple features per row or per date. Y is not two-dimensional, it's one-dimensional, because Y is just one column, not several. All right, so after we have fit our visualizer through the data, we're then going to have to transform the data with visualizer.transform X. And visualizer, finally, we're going to call poof, which is going to show the data or draw it, but it's called poof. Okay, then we'll run that function, or cell, we'll run that code cell, and look at this. The title by default is Shapiro ranking of 1,258 features. We have the columns on the Y-axis, and on the X-axis we have the ranking. So it looks like the most valuable feature from X, the highest important one to determine Y, was returns. Next was volume, and then after that was decrease by, and then after that open, high, and low were tied. And that makes sense that those would be the ones that had the most effect on the Y, or the adjusted closing price. Note that adjusted closing price is not included here in our columns because that is our y, so it can't be in our x. And you'll notice as well, I didn't put it inside of our x because we can't have the y be inside of x because we're trying to predict y. As well, there are other forms for finding feature importance. For example, we can use rank 2D to create a two-dimensional rank known as covariance ranking. So let me create a new code cell here. From yellowbrick.features, I'm going to import the rank 2D class. Then again, I'm going to instantiate rank 2D, passing in my features. This time though, the algorithm is going to be covariance for two-dimensional ranking, and the result is going to be our 2D, or let's call this our visualizer 2D. All right, and I'm just going to make that D capital so we know its dimensions. Then I'm going to call visualizer underscore 2D, and I'll call the fit function to fit it through our x and y data, the same data. Then visualizer 2D dot transform, so very similar process. And finally, do you remember the last line? It's visualizer underscore 2D dot poof to show the visualization. All right, I'll run this code cell and look at this. We now have a covariance ranking. So it's a different type of ranking. It's now two-dimensional. One is at the top, so we can see that that is the highest importance of feature per all of the others. All right, so slightly different here. We have reds for high versus open, low versus open, and beige, which is slightly less important for returns versus open, returns versus high, and returns versus low. Then if we have a dark blue, that means we had -1 correlation. We had that for decrease versus volume. All right, and that makes sense. So now we're comparing the features' importance in terms of covariance.